How can you fix bandwidth problems in signal amplification? Imagine trying to listen to a song on a radio station that cuts out every few seconds. That annoying interruption is similar to what happens when an amplifier can't handle the full range of frequencies in a signal. When signals have a wide range of frequencies and the amplifier can't keep up, it causes distortion, signal loss, or slower data transfer. So, how do engineers fix these issues? Let's explore some practical ways to improve bandwidth in signal amplification. First, choosing or designing amplifiers with a wider bandwidth is key. These amplifiers can handle a broader range of frequencies without losing fidelity. Think of it like upgrading from a narrow radio to a high-fidelity stereo. Next, using broadband amplifiers is a smart move. These are built to give flat gain across many frequencies, so your signal stays clear and consistent, no matter the frequency. Another important factor is the gain bandwidth product. This number tells you how much an amplifier can amplify at a certain bandwidth. To keep the bandwidth wide, avoid setting the gain too high. High gain often shrinks the bandwidth, so balancing the two is essential. Applying negative feedback in the circuit can also help. It reduces the gain slightly but boosts the overall frequency response, making the signal clearer over a wider range. Reducing parasitic effects like unwanted capacitance and inductance in the circuit is also vital. These tiny elements can act like filters, blocking certain frequencies. Careful circuit layout, good component choices, and shielding help keep these parasitics in check. Proper impedance matching is another trick. When the amplifier's impedance matches the source and load, it allows maximum power transfer and keeps the frequency response flat. Using multiple amplification stages instead of one high-gain stage can also help. Spreading the gain across several smaller stages preserves bandwidth and prevents the signal from distorting. Managing temperature and noise is equally important. Cooler, low-noise components keep the signal clean and maintain bandwidth over time. Advanced technologies like distributed amplifiers or traveling wave amplifiers distribute gain across multiple devices, giving very wide bandwidths. Lastly, signal conditioning and filtering before amplification can prevent out-of-band signals from causing overload or distortion. For example, using filters to limit the input to the desired frequency range keeps the amplifier working efficiently. In real-world applications like cellular signal boosters, these principles are put into action. Wideband amplifiers and antennas designed for multiple frequency bands help maintain signal quality over large ranges. Proper installation, with outdoor antennas placed where signals are strongest and indoor antennas rebroadcasting, can also improve bandwidth and overall signal strength. To sum up, fixing bandwidth problems involves selecting the right amplifier type, designing circuits carefully, balancing gain and bandwidth, and matching impedances properly. These steps help ensure that the amplified signal keeps its original quality and frequency content, which is essential for good signal processing and control systems.